So welcome to UV Physics Academy. So here we are discussing the solutions of quantum computation. So this is our next question. This is a very interesting question. So here we are going to check this condition, that is a trace of rho square is less than or equal to 1. So this condition will decide whether the given state is a mixed state or pure state. If it is equal to 1, it is a pure state. If it is less than 1, and it is that is a mixed state. Okay, so let us start. Now here first I am taking this block sphere. Okay, so this is x-axis, y and z. Now I am assuming a point on the block sphere, for example. So this is the point corresponding to the point on the block sphere. Actually, what is this point? This is the eigenstate corresponding to spin measurement, that is n cap dot sigma bar. In my earlier classes, I have already discussed this. Please go through that lecture. So this eigenstate is nothing but cos theta by 2 e raised to I phi sin theta by 2. Fine. So now I am going to define the density operator corresponding to this point, which is nothing but the outer product here psi. Okay, if I substitute this and simplify, I will get this 1 by 2 into I plus a bar dot a sigma bar. So here I am not deriving because the next question is about this only. I will derive this expression in the next question. Okay. So this is the density operator corresponding to the point on the block sphere. Fine. So more generally, how can we write this? So now I am taking the general form, that is a density operator corresponding to an arbitrary point. So just I am writing like this 1 by 2 I plus r bar dot sigma bar. Actually here, what is the magnitude of this a bar? So this corresponds to the point on the block sphere. So that definitely that magnitude of a bar should be equal to 1. Then only we can say that point is on the block sphere, and that is called a pure state. Okay, so now generally I have written like this. So what is the meaning of this? If the magnitude of this r bar exactly equal to 1, then the point lies on the block sphere and the state corresponding to that state is called pure state. So this is on the block sphere and the state we call it as a pure state. And if somewhere inside, okay, so then the magnitude of this r bar should be less than 1, and this we call it as a mixed state. Fine. Now come to the question. So here we are going to show that is a trace of rho square. So we have to find this trace of rho square here. Let us find a rho square first. So what is a rho square? 1 by 4. This is I identity plus r bar dot sigma bar, okay, whole square. Now this is a plus b whole square, a square plus b square plus 2ab, and here no need to write that total expression because our aim is to find a trace. So there is one thing, that is a trace of sigma square. Trace of sigma square. Sigma square, I mean sigma x square or sigma y square or sigma z square, which is nothing but a trace of identity, which is a 2. But if you take the trace of any Pauli spin matrix, it is a 0. So by using this, I'm going to write trace of rho square equal to 1 by 4. Just I'm applying this trace. That is a plus b whole square. I am not taking the cross terms. I am taking only a square and b square. 2ab term I am not taking. The reason is, if I take 2ab, here I will get r bar dot sigma bar. So then it is nothing but x sigma x plus y sigma y plus z sigma z. And if you take the trace, there we got trace of sigma x plus trace of sigma y plus trace of sigma z. Of course, x, y, z are there. Okay. So then it is equal to 0. So that's why I'm not taking that cross term. Okay. So trace of identity square plus trace of r bar dot sigma whole square. And again, So this r bar dot sigma whole square is nothing but x sigma x plus y sigma y plus z sigma z whole square. And again here I am not taking the cross terms. I am taking only that squares. So finally I can write the trace of rho square equal to trace of rho square equal to 1 by 4 trace of I square, that is nothing but a trace of identity, which is a 2 plus. Now carefully observe, in this a plus b plus c whole square, I will take only that square terms. That's why x square trace of sigma x square again 2 plus y square again the trace of sigma y square 2 and z square the trace of that sigma x square sigma y square sigma z square just taken common, that is a 2. So finally we got, so trace of rho square we got 1 by 4 into 2 plus 2 into x square plus y square plus z square. What is x square plus y square plus z square? Mod r square. So this is 1 by 2, 1 plus, we can write this as mod r, magnitude of that r square. Fine. So this is the trace of rho square. Now let us take the conditions. So we have two different points. One is on the block sphere. If the point is on the block sphere, that state is called a pure state. What is the meaning of that on the block sphere? The magnitude of this r should be equal to 1. Then if you take this condition and substitute, then this trace of rho square equal to 1 by 2 into 1 plus 1, which is exactly equal to 1. Now if I take the point is inside somewhere, then we call this as a mixed state. So for that mixed state, we have to take this magnitude of r is a less than 1 because the point is not on the block sphere. So just take it and substitute, then we will get a trace of rho square definitely less than 1. So that's it. So trace of rho square is equal to 1 for pure state and less than 1 for mixed state. Okay, thank you.